Alright, this video is rated PG-13. If you have children, please make sure that you turn their eyes away. If I have 1/5 plus 1/2. See, I've gone and ruined everything now, right? And this right here is where students just stop and they freeze. I will not allow you to do that if you're going to be my student. You will learn how to do this without freaking out. We talked before about writing equivalent fractions, right? Fractions that had the same meaning, but their denominators looked a little bit different, right? What we need to do is we need to find some common ground between 5 and 2. Find what we call the LCD. What's the LCD stand for? It's the least common denominator. Now there's a really easy way of doing this. Oh man, I can show you how easy this can be. I'm going to have to create some supplemental videos for you for this. The LCD doesn't have to be used. All you need is a common denominator. Why do we throw the L in here for least? So you don't, maybe you won't have to reduce later, which is not a guarantee, but having the least common denominator is the smallest number that's common to both of these. And you've got to think about their factors. What's the smallest number that both of these guys can go into? 10, right? If you were to look at the multiples here, start with 5. Does 2 go into 5? No, so 5 is not a common denominator. What's the next multiple of 5? It would be 10, right? Does 2 go into 10? Then you can stop because this is going to be your LCD. So my question to you is, how do I turn this 5 into a 10? What factor is missing to become a 10? A 2, do y'all agree? So I'm going to write this just a little bit differently for us. I've got 1/5 plus 1/2. And I'm saying that I want to convert these guys to be fractions that have a common denominator of 10. So you guys said that the missing factor here was a factor of 2, right? Did I multiply 1/5 times 2? I did not multiply 1/5 times 2. I multiplied 1/5 times what? 2 over 2, which is a form of 1. So 1/5 is the same as 2/10. Do y'all believe that? That's what we did a few sections ago. Now, what factor is needed to turn the 2 into a 10? So we multiply both the denominator and the numerator times 5. So we end up with what? 5/10. So now that they have the same denominator, we can compare these guys correctly. So what is the addition problem now? What do we have? 7/10. Can I reduce 7 over 10? Nope, so this is your answer. Is that enough for us to freak out yet? Yes? Okay. What if I were to say this? Well, see, now I had a number that I decided to change it. 3/20 minus 7/10. Do we have the same denominator? No. But it's pretty easy to find the common denominator if you start with the largest denominator first. Start with the largest denominator, which is 20. Does 10 go into 20? Oh, so this right here is going to be our LCD then. It doesn't always work out that nicely, but it is something we can try. So, do I need to do anything with this 3 over 20? He already has the denominator we need. What about the 10? What would you do to convert this guy to be over 20? Put in the missing factor of 2. So then here's what my problem looks like. The 3 over 20 is still 3 over 20 minus, what did 7 over 10 become? 14 over 20. So when I combine these guys, my answer is going to be over 20. And so this is 3 minus 14. Do y'all agree with that? And what's 3 minus 14? It's negative 11. Now, you could say this. You could say negative 11 over 20. But most often the way that we write negatives with fractions is we write the negative at about the same level as the fraction bar. And we just say 11 over 20 like this. This is the preferred way of writing it. So far, so good? All right. Now it's time for destruction. Or just hinting at destruction. Yes?
If it's at the same level as the bar, how do you know what the negative applies to?
That's a good question. So if you're saying with the negative out here, how do I know if it's the negative 11 or negative 20? How many negatives do you have here? 1. So it's either going to be negative in the top or negative in the bottom.
Okay, so if it's the 20, then it'll be lower.
Say again?
If it's for the denominator, it'll be lower.
Well, see, this is the problem. We don't leave negatives in the denominator like that. That's weird and it's gross. Okay? What's a positive divided by a negative number? A negative, right? What's a negative divided by a positive number? It's still negative. So we just write the negative in front of the fraction to denote that it's a negative number, which means its position on the number line is going to be to the left of 0. Okay? Does that make sense? So we're probably going to stay away from negative denominators, but if they show up, just move that sign out here to the front, just like I have here. But you'll see more of those guys later on. If I take 5/8 plus 1/6, one of the ways we were talking about finding the common denominator was taking the largest number, here the 8. Does 6 go into 8? No. What's the next multiple of 8? 16. Does 6 go into 16? No. What's the next multiple after 16? Does 6 go into 24? Then this is the guy that we need to convert these guys to. Okay? So if we were to scratch this out, what does 8 need in terms of its factors to become 24? 8 times what gives you 24?
3.
So you're missing a factor of 3 here. What is the 6 missing? 6 is missing 4. Check your math when you do this. What happens here? 5 over 8 becomes what? 15 24ths. Plus what? Now do you have the same denominators? So now you can do what? Add those numerators, and what do you have? All right, I've got 19 over 24. Is this in lowest terms? Yeah. Now, here's another way of looking at how do we come up with that 24. If you take 5 over 8 and 1 over 6, look at the factor tree for 8. 8 breaks down as 2 times 2 times 2. Do you all agree? How does 6 break down? 2 and 3. Is everybody with me on that? Okay. Do these guys have any factors that are common? What factors are common? So this guy has a 2 and this guy has a 2. Is there anything else they have in common? No. Now watch the magic. You want these denominators to be the exact same number, right? And we told you before that each number has its own unique prime factorization. That means if you multiply a set number of numbers together, that only gives you one number. Take these factors here and multiply them over here. Take the number here and multiply it over here. Okay? Now I don't want you to freak out. I want you to look at this. Look at your denominator. Your denominator is comprised of the factors 2, 2, 2, 3. Do y'all agree? Look at your other denominator. It's made up of 2, 2, 2, 3. These are the exact same factors. Do y'all agree? And what happens when you multiply all of this together? You get the same number, which is 24. But what that lets you do is that you don't have to worry about going through the multiples of these numbers. You can just look at their factors in the denominator, and you still end up with the same answer here, which is 19 over 24. Now this is a technique that we're going to explore a little bit more later. But if you look at the factored trees and you see the prime factorizations, you know what's missing from each denominator so they can become exactly the same.